I know exactly what you're thinking. What's the future of poinsettias? Well, it's the fully automated farm. Costa Farms is going to talk to us about the solution that fully automates their farm. It's incredible. It's right now on Dev Radio. And welcome to the next episode of Microsoft Dev Radio. I'm Jerry Nixon, and I'm here with Costa Farms. Well, specifically, I'm here with Rodney and Manny from Costa Farms, and I'm here with three of my favorite evangelists, Joe, Blaine, and David. But before we get started there, Rodney, you work for Costa Farms. First, who are you?
Hi, my name is Rodney Sanchez. I'm a software developer here at Costa Farms. I do most of the web development.
Excellent.
And I'm very excited to work on this project with Microsoft.
Very cool. And Manny, you're with Costa Farms too. You want to introduce yourself? Thanks for being on the show.
Thank you. I'm the BI architect here. I've been leading the project for the IoT implementation. It's been a fun project, and very happy to talk more about it.
Great. Well, a lot of people may not know who Costa Farms is. Manny, could you just give us kind of an introduction of who they are?
Sure. We supply to big box retailers. We are primarily ornamental plant growers. We have about $400+ million of revenue, and we have the different kinds of plants that you could imagine, poinsettias, orchids, a lot of indoor plants that you see. We grow a lot of them here.
Very nice. Joe, you're back on the show. Hey, man, what did you do on this project?
I handled the back-end piece in Azure. So basically all the sensor data that we were pulling from the devices, and it was processed in Azure, and I handled putting all that together, and then lastly communicating that back down to a cell phone through Twilio.
Very nice. Blaine, you developer, you tell me what's your role on this project?
Moving to the dark side, Jerry, from IT Pro to go to touch a little bit in IoT. Use the Adafruit Feather, the M0 Wi-Fi to connect to my MiFi that connects to Azure and sends that pH data to the cloud. So I helped build those devices for implementation.
Oh my gosh, I cannot wait to start laying out what this project is. It's so cool. All right, David, hey, what are you doing?
Hello. Mostly just diagnostics and fixing anything that didn't work properly.
Got it. Everything Blaine made, basically.
Yeah, if Blaine made it, I was on top of it afterwards.
Yes, C code. Thank you.
Nice.
Wrote a lot of C code working with Arduino and some new Arduino devices that were new to the market. So trying to just figure out how to get stuff to work that is on new devices.
Okay. All right. So this is part of our proof of concept initiative where we have a program to build leading edge technologies for customers to really be able to see their data and their workflow in real life. Start by talking to me about the problem. Tell me, David, what was the issue to start with?
The main issue to start with was that the growers who would go around and work with the various plants were spending a lot of time collecting pH information. pH is one of the key metrics for plant growth and health. So if you had an imbalance in your pH, you would actually have a visitor. You'd actually have an issue with the growth of the plant. So we wanted to reduce the amount of time that they were spending monitoring pH levels and increase the time that they were doing more meaningful things in the business.
Okay, Manny, talk me through this. Before we got started with this project, how are you handling pH balances in all of your plants?
So right now it's a manual process. We have growers actually going to the, some places you have machines that kind of tell you what the pH levels are. They either go there manually, write it down on a piece of paper, come back. In some places, they have something called a pH pen, which they actually go in and insert into a tank, rotate it, and measure it manually. They do this multiple times a day. So imagine if the pH levels are off and if you need to make a change. So it makes you having to go to that location not just once, but constantly monitoring it, going back and forth and measuring it multiple times a day. So it's not just a waste of time, but let's say we're in Miami, but it does get cold once in a while. Let's say you're having a really cold day. Now you have a grower worried about the water quality, and he has to drive out there in the middle of the night trying to figure out what his pH levels are. So that's the problem we are trying to solve.
Blaine, whenever you hear about a lot of manual work like this, what kind of solution do you start to think about?
Totally automation, right? And as we look into even the IoT side of things, we look at either remote monitoring or predictive maintenance, and so I think it kind of does both of those in the solution, and more importantly, taking that proactive approach, right? Instead of being reactive on the levels, getting notifications, and Joe did a great job of sending those notifications to Twilio and letting the growers know what's going on in their crops real time. So automation.
Joe, when I'm automating the measurement of something and I'm getting accurate data that's very precise, I mean, if I send you out to measure something, you'll do a good job, but there's a kind of a wiggle room of error. How valuable is accurate data over time and a reliable cadence of receiving it?
Well, I would think it's very important. I mean, that's the whole point of what we're doing, is that we're basically giving them, this real-time data so they can act on it and they don't have to have someone driving out there in the middle of the night.
All right, talk to me about the devices. What were they like, Dave?
So we start with this M0, which is a new device from Adafruit, Arduino-based. So it was kind of cool to use something that was a standard Arduino-based device and connect it up to Azure IoT Hub. So a lot of times you see folks using Raspberry Pis. They're a bit more expensive than this, but this has built-in Wi-Fi and was easy to connect up to the pH sensor, and also equally easy to connect up to IoT Hub and just use standard C libraries. So it was exciting to see something a little bit more closer and closer to what you'd actually want in a production ecosystem.
All right, so I have these small devices now, and how many do you need to really be effective, Manny?
So we have multiple locations spread across. So we are not just in Florida, we also have some locations in the Carolinas. So you're talking about really big farm acreage. To start off with the POC, we are starting off with 2 devices. Okay. But we do see that we are going to use multiple devices wherever there is water input, like tanks or reservoirs. We are going to put that in there.
Okay. With devices like this, probably have a lot of risk, at least to the environment and the elements out there. What can you do to a device like this, Blaine, to kind of protect it?
Well, there's a couple of ways you can do it. You can do like maybe a 3D printer, a compartment you can put the device in, keep it from getting wet. There's also, I've seen some plexiglass ones you can make with some laser cutters and do the dimensions and retrofit these devices inside. But you definitely want to keep them dry, especially when they're got a pH probe coming at them that actually goes into the tank that does those readings. So there's a couple of ways you can secure the device first, and then build a compartment around it, keep it dry.
Or if you got stuff you're already at a facility that has water, those little sprinkler cases that you can buy for your sprinkler control board outside, just stick it in there and hot glue it to it.
Sure, why not? All right, Joe.
Cheap,
we got a lot of farm here. We've got 2 units, but now we're going to keep rolling these out. The next one, the next one, the next one, the next one. That's going to be a lot of data rolling in. How do you handle that sort of volume?
Basically through Azure IoT Hub, which is designed to handle millions of messages every second. So basically, these devices send the messages up to Azure IoT Hub. We're then throwing them into an event hub, and then basically using Stream Analytics from there to look for messages that reach a certain threshold. So if that pH is over a certain level, we're going to send a notification out so that they can act upon it.
How many devices do you think we can start sending through IoT Hub before you start reaching capacity?
That's a good question. I would say a lot. I would assume thousands.
It's in the millions. The documentation indicates in the millions.
That's the whole thing about using the cloud, right? Scalability, and there's infinite, right?
Yeah, 1 billion devices.
And if you get if you get to a point where you're fully consuming one of your IoT hubs, you can always stack another IoT hub on top of it and then have another stream analytics, and then those feed and aggregate into a second one. So you can tier these services if you have those types of needs. I have yet to actually need to do that.
Sure. Well, David, on that point, one of the things we're going to monitor is to make sure plants get what they need and all that. But you also will eventually be building in monitoring the devices themselves to make sure they're still working.
Yeah, that's something that we could definitely do. There's so devices themselves will go bad over time, likely due to temperature, humidity, weather exposure, variety, things like that, which happen to be the same types of sensors that they're looking at adding into production anyways. Those types of, the sensors themselves are very, very cheap. The board is a little more expensive. So you could actually correlate the times that devices go bad with the temperature and humidity and other information that you collect based on each location, and predict when a device is likely to go down before it goes down, and just have somebody go in and swap it out for you.
Sure. Now, Rodney, I assume IoT Hub is not something that was part of the original architecture or something that Costa Farms was using originally. How do you engage with developers as they come in and they're starting to do all of this really cutting edge technology? How do you react and how do you collaborate with these guys?
Well, it was a very interesting experience for sure. We got exposed. It was the first time that we worked with Azure and with this amazing team. It was very interesting because you were able to get like a sensor and a couple of ideas, and in a couple of days we were able to build something and something useful that was working. So everything from the sensor to the Azure platform, everything was new and interesting.
Yeah. Now, Manny, that's a good point. There's a lot of moving parts, a lot of sophistication of things to accomplish. What was your impression of how fast you could put this sort of thing together?
I think it all comes down to the usefulness of it. So when we proposed this to the grower and showed them what we can achieve, you just had to see their faces, it just lit up. They were like, I want that. So I guess when the product is useful, and also I didn't know how long it would take to set this up. When Blaine and David said 2 days, I was like, I'm not sure if 2 days is going to make it happen, but we got it done in a couple of days. And Rodney and I did some testing afterwards, and we were actually doing testing in terms of we went and measured with the pH pens that they actually used and measured with the device that we built, and they were like very close, like the accuracy was there. So it's amazing how it's easy when you see it from people like David and Blaine and Joe, because you learn from the best. Then you know what are the different moving parts and how to put it together, the architecture of it. But once you get that conceptually, I think it's pretty straightforward. You can pretty much do this.
Okay. Well, Manny, let's keep talking about business intelligence. Now that this sort of information is coming in, what do you see that you'll be able to do with it?
One thing that we are pretty excited about is it gets missed, but the board that we built out was meant for one pH sensor, but you can put up to 15 sensors on that board, is what David told me once, and that just blew us away, because now you can have like pH, EC, humidity, temperature, anything you can think of on one board in one place. Imagine getting all that information at once from different locations, and there are multiple things you can do with it. The first thing is the monitoring. Of course, you want to help the grower and make better decisions and let him spend his or her time doing things that are more important than going and trying to check your pH levels every often. But also, once you collect all this data, imagine you can ultimately tell for a specific genus, series, variety of a plant, what are the optimal levels of different health measures, like what would take a point for a poinsettia, what makes the best call, what is the light or water quality for it to grow the best. So that's the ultimate goal that I see with all of this.
It's like, that's the dream, no doubt about it, all that information. Joe, how do you get all this information, how do you expose it back so that Costa Farms can make use of it?
Oh, basically through Stream Analytics, we're taking a copy of all the raw data and we're dumping it into an SQL database. And as Manny was saying, we built it so that it's not just for pH. So when we send the data up, it's a simple JSON object, and we just put that it's a pH sensor. But if we want to add a temperature sensor, we just change that text field to temperature, and then it all goes into an SQL database, which Manny can easily plug Power BI into, and then do some nice visualization from there.
And the solution that you built so far, it actually has some reactive pieces to it, where if it starts to detect certain things, it can reach out and give an alert to Costa Farms. Walk me through that.
So basically, when we send the data up to Azure, we're sending in the current value and then what the threshold is. So basically, if the value is outside of the threshold, let's say the value is 6 and the threshold we're sending up to it is between 2 and 4, it's going to then, we have a function that goes ahead and sends an alert through the Twilio API, and then they get a text message on their phone so that they can act on it. So it's a pretty simple setup, actually.
Nice. Twilio saves the day again. Quick little text message. So easy to do too. People don't even know. Dave, tell me a little bit about as you picked out these devices. You didn't pick a Raspberry Pi. Tell me why.
The cost and the ability to kind of move around with the Arduino platform. So going with a Arduino-based device, it's super easy to get up and running with. Install Arduino Studio, write some C code, and deploy it very easily. With the Raspberry Pi, there's a lot more steps involved. So if you want to get off the ground running really quickly, you're setting yourself back a couple of days with a Raspberry Pi. But then also when they go to production, you can simply plug in each one of these things and just load the code. Now you've got one with the code ready to go, and it's just a matter of plugging in whatever PCB board you've designed that you've received from a manufacturer. So from a going to production perspective, I highly prefer the Arduino. Also, the real-time operating system allows us to start tinkering around with actual autonomous functions. So once they see something like this, like the pH going out of bounds, instead of it sending a Twilio text message, you could use IoT Hub to send a message back down into the Arduino device, which has all the capabilities that you need to actually actuate motor, servo, so forth and so on, and it could actually dump in the pH level. So there's kind of a plan here, and I want to start somewhere that's easy but also has a path forward to get as sophisticated as you want.
Blaine, we had a team of 3 evangelists as developers on this project, and 2 days, is that real?
Yeah. It was roughly 2 days. I know we spent some time at the hackathon kind of going over some of the prereqs and doing some things around getting the device kind of built in prototype before we went on site. So we had a little bit of work done, but really it was about 2 days, Jerry. You know what the interesting part about it was? I just really like the collaboration between Rodney and Joe and Manny and doing the code. Like Joe and Rodney were just coding away and they're just working together and writing bits and Rodney, Joe's like, just write this piece of C#. And he's like, Rodney just knocked it out. And Joe's like, okay, well that worked. So they went to the next thing and they just kept building and building. It was cool to see the interaction to building the actual solution of something that was real time that would help, Costa Farms with some of the bigger problems that they had. So that part was really cool to see.
Joe, how formal was it? What kind of tooling did you use? How'd you handle tasks? How'd you handle source control? How'd you handle all of this business?
We set it up pretty simply. We used GitHub for all source control, and we did everything in Visual Studio. And what was great with Azure, tons of great documentation specifically around IoT Hub. So it was we started by diagramming everything out on the whiteboard, which I think a lot of meetings normally start with. Once we all agreed that it was right, then we just kind of divided and conquered. Like Blaine said, Rodney, you write this piece of code. Let me see if I could figure out how to get IoT Hub and Stream Analytics set up, and then figuring out, through Manny what data points she needs, and then, just going from there. But everything was done through GitHub.
Now, Rodney, when you were so you've never used this technology before, right? You haven't done Stream Analytics before and all these pieces. How did you feel the learning curve was for other developers that might be watching and wondering if they could do the same thing?
Yeah, it wasn't almost any learning curve for what we did. I was surprised how easy and simple Joe and Davey and Blaine made it for us. It was really simple.
Give me something neat about it. What's something that you felt like you really will take away from this as a valuable technical skill that you picked up?
Well, working with Azure, the experience of having a sensor, because I'm not a hardware guy, so having an electronic component reading some pH level, and the next second it flies through a HTTP to an API, and you have it in a SQL database. That's something that is amazing.
Yeah. Now, Manny, now that you have all this information, and now that the information is so much cheaper, where you don't have to pay for every single time it's measured, it's just being measured at a reliable rate. Do you think there are new questions that you're going to start asking that were just too expensive to ask before?
We've already started asking those questions. So we've been meeting with multiple growers, and I've been kind of collecting requirements so as to what are some of the other pain points that they have. For instance, what goes in hand with pH is EC and alkalinity. So those are some of the other questions we are thinking about tackling. But this project gave us, in a way, the head start and the courage to go after bigger things.
Good. So it sounds like not only was the vision accomplished, but a much larger vision that was kind of hidden behind the cloud there, that once you started to kind of peel away the layer, you saw there was more you could actually do. Dave, let's say I'm a developer and I work for another farm, one that's in, California or something, and I'm like, man, yes, automated measurement. This is incredible. How reusable is this project? How useful will it be to other developers who are looking to do similar things?
I think the same paradigm and architecture that we use for this is applicable to autonomous farming as well as almost anything. I mean, and this same architecture is almost the same stuff we use for the brain signal processing and a variety of other projects that we've done as well. So, just think, if I need to collect data from some thing in the physical world and I want to do something useful with it, then follow along with this kind of paradigm and you'll be in a good position.
Yeah, just collect the data, toss it up to IoT Hub, go from there. I mean, it's crazy because we draw out these architectural diagrams for every solution, and if you step back far enough, every solution has the same architectural diagram, just with different words on the boxes,
Yeah, this true. One is plants, this one is SQL, this one's brains, this one's no SQL. It's the same thing. It's data from point A to point B. Something's moving it in the middle.
What do you think, Joe? Was Azure a good choice?
Of course. Azure was the best choice. Mainly, honestly, it was the tools that we have there make it easy to get started. So for Rodney's example, he had never worked with these type of tools. We have a lot of guidance in the tools to get you started to set up IoT Hub. It's a couple clicks, you fill out some information, and it's set up 5 minutes later. So for someone new that has never done this, Azure is the way to go because we walk you through the process and provide all the supporting documentation and videos.
Cool. Now, Blaine, how far are we from production? We know this is just a proof of concept.
Yeah, so we've completed the devices, we've completed the Azure work. Joe and Rodney and Manny and David, we've all collaborated together. We've handed this off, so we're looking at a couple of months to get this up and running and add more devices with them. And so, yeah, it's going straight ahead, full steam.
And here you are in the cloud. It's not like we need to go buy more servers, right? We just start scaling this baby up as soon as we start getting all the hardware in place so we can measure this and start sending information.
It's the first time they've used Azure for solving problems in their field operations, and so yeah, it's exciting to see it take off.
If we could go back 4 years before Azure was even there, isn't that crazy that 4 years ago? But anyway, if we could go back 4 or 5 years, and there's no IoT Hub, all of these things are really hard to do. 2 days to get a project like this off the ground, impossible, right? We'd all be scoping out server class servers first, and then we get Windows installed, then we get SQL installed, all these things you'd have to do. And now you just click the button, you're like, hang on, full 12-second wait, right? Okay, we're ready to go.
Right.
It's sort of crazy.
I mean, like building all that stuff out, right? Like how long does it take from procurement to getting the hardware to the provisioning of all the servers, putting SQL on top, and then making sure to test everything out, and then roll that into a proof of concept. That alone would take a few days.
Just to get time.
With
But the
stretch.
cost
Costa
savings.
Farms, and Joe, Costa Farms gets to decide really a lot of the cost as well, right? They can scale so big or not so big, and then even when they're fabricating whatever box this goes in and everything like that, they get to choose just how high a quality is. Or I don't know, Dave, these are kind of throwaway devices. You're paying such a small amount. You could really have a developer like Rodney go and say, let's just build 100 of these. We're going to use 50 at a time, and as they fail, we're just swapping these babies out because they're, what are they, $100 maybe?
Nah, there's a new one that's $3 that'll work just as well. So
Right.
the
So
pH sensors
you'd
the
never
phone.
pay to fix it. You just pay to replace it.
Just screw it. Yeah, just throw it
Exactly.
away.
It's a brand new economy, that's for sure. And also scalable, also commoditized. Now, Manny, talk to me a little bit about Costa Farms. What do you think is next for Costa Farms?
We are planning to take the current POC device to production as like the immediate next steps, but we are also scoping out the big picture of what are all the different devices that we could add to make a fully connected farm to begin with that helps our growers, and not just that, to also control and reduce the inputs that we use, manage them better, and also bring out a really healthy plant. That's the next thing.
Beautiful. I saw on the news where in the next 20 years we're going to need 70% more production of food. So maybe it'll be projects like this that inspire the world on how to solve some of these big problems. And look at it. I mean, here we've got Joe Blaine and David. If they can do it, every
Gee,
developer
thanks,
watching
man.
should know in their heart, hey, I could figure this out too, right? Because
Very
hey,
true.
it's seriously right there. And here Rodney comes in. Now he's an Azure expert, and it just took 2 days for Blaine to be able to just do the mind meld with him. Guys,
Solving
thanks for
world
being on this
peace.
show. I know you can do everything with Azure. The answer is Azure. We're going to start hearing Azure now in beauty contests. When there's like, what do you think it should be? No, seriously. Rodney, Manny, thanks for being on the show, talking to us about what you're doing here with Costa Farms, your vision, and inspiring other developers and other, honestly, farms and agricultural industries to be able to do this in a way that's approachable, that's cost efficient, and isn't a gigantic investment that'll take years to get there. They can start seeing a difference really, really quickly.
Thank you for having us.
Thanks,
Thank
Manny.
you very
Thanks,
much.
Rodney. Bye, guys.